talk that's longer than the 5-10 minute interval, but one thing that I committed to is that we try to keep these talks to under 5 minutes, so 7 minutes, and total lap time is 10 minutes. So Ashiq's going to break his talk up into 2 chunks, which is perfectly reasonable, and so there'll be some speaking in between Ashiq's talk.
So I found this picture, and I thought it would be kind of very cool to show and set the tone of my talk today, right? And people who know this industry, we can really have fun with it, especially this one, right? Deep learning is amazing, but if you ask the theory people, there's really not that much solid foundation, right? People who don't know, there's Ian LeCun. This is one of the 3 godfather or mafia, depending on perspective, of deep learning. He runs the AI research in Facebook. Actually, many of the things that's basically coming out is coming from him. So, if you look at deep learning and if you look at people's background, right, and they see it differently. So let me tell you a little bit of me so you know where I'm coming from. Because when you ask the same thing to different people, they all say differently. So for me, who am I? So, quick way to describe, I'm a problem solver with technology. I have my undergrad math and physics, grad school quantum optics. Last 18 years, I've been trying to help companies make data-driven decisions. Right? In my current role, I make the senior executives, you're talking about C-level, senior VPs, to decide if they're going to put 20 billion investment or 30 billion fixed investment in a product or not. And I build what I call a decision support platform. Because everything that we do, machine learning, classification, or how does it help? You help the business to make a decision, right? Hopefully with the help of data, so that they are more guided. And the way I do it, you pretty much have to do the data science full stack. That means the ETL, all the dirty job, processing, and some kind of visualization layer on top. And I run the Tableau server in my company as well. So in short, if you're familiar with the movie Pulp Fiction, this is what I am. I solve problems. Right? People always talk about their own work. I want to say a little bit of my personal thing. The reason I work so that I can do all this stuff. This is my coffee station at home. If you have any question about coffee, Argentine tango dancing, I do DJ. There's the event in Clyde Park this July 24th. I invite instructors come and dance. My latest passion, sailing. Where's Scott? I drag him there on Wednesday night for sail racing. So I can talk about it all in another session like this. So let's go to deep learning. So I remember hearing the buzz about deep learning around 3-4 years ago. And at that time I said, well, I don't care. It's something that the image processing guys are worried about. And random forest, that was a big thing at the time. It was good enough. We didn't have XGBoost, right? So if I have random forest, I can solve any problems. Right? And then beginning this year, right, AlphaGo happened. There's the Google program or Google bought a startup 4 years ago called DeepMind that made the Atari game just looking at the pixel and you could play the game. So Google spent $400 million to buy the company. And last 3-4 years, they have been training to play this game called Go. It's a Chinese game. The combination of moves are astronomical. It's like numbers of atoms in the world. And DeepMind solved it. And it's a reinforcement learning problem. And instead of the traditional way of Q-learning, they used a deep learning architecture. And that got my attention. I said, oh man, this is big. And I've been ignoring this thing for the last 4 years. I got to learn these things, right? So you go to the literature, you try to find out, what it's all about, and you find all these other terms. We have no idea what they are, right? Because that's usually are. If you ask the technical guy what it is, they'll try to explain you with another 10 different buzzwords, right? And you're completely lost. So the way it works, you go to the theory guys. Well, actually, first you get lost in the forest, right? You probably heard the term, can't see the trees for the forest. This is exactly how I felt 4 months ago. If you go to the theory guys, right, they'll try to write the equations. So there's a front propagation equation with layers, you're almost lost, right? That's not worst. The worst part, if you go to the real theory guys, they'll say for any f, there's excellent, blah, 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 blah. All they're trying to say that, with a neural net, you can approximate any function, and they're done. Right? So that's the theory. So now where do you go? So let's go to the code guys, right? So if you go to the code guys, right, they'll say, oh yeah, we have keras, and I'm using TensorFlow in the backend, and I'll kind of run it through, right? It's kind of, well, I'm putting one dense layer with a ReLU activation and another dense layer with another ReLU activation, and the end softmax. I'm using loss as cross entropy, loading the data, training it, I'm done. That's my hello world of image recognition of numbers, right? Actually, in this case, almost 98% accuracy. Now, if you are a manager, you might say, dude, if I know how to write code, I won't be in a management position, right? Give me an elevator speech, right? So let's talk about a different approach. Let's talk about layers. So I have asked some people, and they told me, deep learning is all about layers, right? You put these computational blocks one after another, and it becomes deep, and that's deep learning. And you can also almost think about it, right? It's all about the layers. It's kind of true, right? You put the right junk in the right place, you get the results. Believe me, think of the ImageNet competition, right? So the Stanford guys, they run these competitions. There's like 14 million pictures, right? And people give them a sample and say, build the algorithm and see if you can identify the objects. The deep learning revolution really started in 2012 in my mind with this paper by Alex. He was a student of Hinton and University of Toronto. And he has this thing called AlexNet. It had 8-layer systems. But guess what happened? BGG, this came from the Oxford guys. It has 19 layers. Last year, the Microsoft, out of nowhere, the Microsoft research from China, they came with 152 layers. And I heard they're working on, I think, a 1,000-layer system right now. Okay? So, what is all about these things, right? Then you might get lost. When I remember, there was somebody who was talking about layers, that was Shrek from Mogo, right? Onion has layers. Is this what they're talking about? Or, I saw the movie Inception, right? You have dreams after dreams, and Google even named one of their models Inception, and they're talking about dreaming. Okay? Now I'm really lost. Right? Now I'm really lost. The goal, actually this is my personal thing, anything I do at work, right? Sometimes, well, what is the details? Let's take a step back. Let's take a step back. Let's take a step back. What does deep learning, what's so special about it? Right? So that it don't tell me about TensorFlow. Don't tell me about Cafe. Don't tell me about this thing. It doesn't matter how you do it, right? What is this deep about deep learning that's so special, right? It's almost like, you kind of go up of the forest, and you see this beautiful view, right? By the way, I took this picture in Guatemala. It's a beautiful country. It was like 2 miles high in the mountain, absolutely okay. So my goal today is to kind of share with you guys how I convinced myself that deep learning is really deep. So stay tuned for the next half of the talk, and I'll show you how. I think it's probably better to skip the questions and invite the next speaker. And once I finish that one, then you can ask me a question for the next 6 minutes or so.